Welcome Year 9s. Today we're starting a new topic. This is a topic that you'll do further in IGCSE. It's an exciting topic. It's trigonometry and it sounds kind of difficult, but I think you'll find that it's not too bad at all. I want to begin by talking to you about similar shapes. We've talked about similar shapes before, and I think I talked with you once and tricked a few of you, and I said, well, imagine we've got a triangle like this, and let's say that this angle is, I don't know, maybe it's 30, right? Just say it's 30. And when we double the length of the triangle, all of the triangle's lengths, we double them. Okay, so let's just say it's this. What will happen to that angle? Now remember, remember that I tricked some of you, and you thought that, oh, it'll be 60. But when we actually draw it out, when we just double all of the lengths, the angle remains the same. So it's still, if that was 30 in the first case, it would be 30 in the second case. So this helps us understand trigonometry a little bit. Because what happens with triangles, let's say we've got a triangle that's a 1 by 1, this angle here would be 45, and this would be 45. Maybe that's a bit small for you to see, but both of those angles would be 45. Now if I multiplied it by 3, and I get a 3 by 3, so this side's 3, this side's 3, instead of 1 by 1, those angles will still, gee, that's pretty bad, well, those angles will still be 45. And if I make it bigger again, let's say, that's pretty bad, isn't it, really? 1, 2, 3, 4, 5. Right, so I have a 5 by 5. Right, that will be 45 still, and that will be 45 still. So, this fact that when we keep the ratio of sides the same, like the ratio in that first little triangle was 1 to 1, the up side was 1 and the across side was 1, and the next one was 3 to 3, which is the same as 1 to 1 ratio, isn't it? And this one here was 5 to 5, which is exactly the same as 1 to 1. So this idea of ratios is useful in trigonometry, because if we know the ratio of sides, we can figure out angles, and certain angles give a certain ratio of sides. So as I've already shown you, if we have a right-angled triangle like this, and we've got a ratio of 2 to 2 or 1 to 1, let's say 1 to 1, we know that this angle will be 45 degrees and this will be 45 degrees. That's just the rule, that's how those work. But if we have, in our calculators, we have all of the ratios, all the possible ratios between sides of right-angled triangles stored, then we can use that information that's stored in our calculator to make predictions about what the angle of a triangle would be, or what a missing side of a triangle would be. And that's what trigonometry basically does. So what I'm going to teach you today in trigonometry is for right-angled triangles. So we're going to use right-angled triangles, and we're going to talk about this word here, SOH CAH TOA. Okay, so on your calculators, you're going to see 3 words: sin, which stands for sine, and then the next button along will be cosine. It'll say cos on your calculator, and then tangent. Okay, sine, cosine, tangent, sine, cosine, tan. Okay, sine, cos, tan. That's what we're going to be talking about today. Now, sine. We use the S here. We say sine is SOH. And we have O and H, which stands for opposite and hypotenuse. Hypotenuse. Okay, I'm not going to write all of these out because it's going to take too long. Cosine is CAH. So, and we've got A, I'll write this one out, adjacent, that means next to. And then H obviously stands for hypotenuse again. And tangent is toa. O stands for opposite, and A stands for adjacent. So you've got O's, here and here. You've got hypotenuse and cosine and tangent, it's cosine and sine, and you've got adjacents in tangent and cosine. Now, at the moment, you're like, I have no idea what he's talking about, okay? All you need to remember at this moment in time is SOH CAH TOA, okay? SOH CAH TOA. Can you remember that? SOH, S-O-H, CAH, C-A-H, TOA, T-O-A. Now, I'm going to teach you how this all works. Just imagine that this is a nice right-angled triangle, okay? And let's say we have, this is an angle that we know. Okay, I'll call it theta. That's a Greek letter, theta. Now, first of all, when we're labeling triangles, we always label the hypotenuse. So this is the hypotenuse because it's across from the right angle. So that's that. Now, what angle is opposite the theta here? What is opposite to my angle theta? Well, you go across over to here, right? And that is my opposite. And then what is the adjacent? The adjacent is the side that is touching my angle but is not the hypotenuse. So this is my adjacent, right? It's next to the angle. Okay, right? Now let's try labeling a different side. So maybe I'll just make that my theta. Now let's do it with a different color. And we're going to go, we'll call this alpha. Now we're going to label for alpha. Now alpha, the hypotenuse remains here. This is also hypotenuse. But you'll notice now that this one would be opposite my alpha. And this one here would be my adjacent. So the hypotenuse always stays the same. But depending on where the angle is that you're looking at, your adjacent and your opposite might be in different spots. Okay, so I'll try another example of a triangle. Okay, here's my triangle. Here's my right angle. And this is theta. So, where is my hypotenuse? See if you can think where that would be. It's going to be here. This is hypotenuse. What is the opposite to that theta? Well, go across here. That's my opposite. And the adjacent would be the next door to. So this is my adjacent here. Okay. So being able to label the triangles is quite an important skill. We're going to go on now. We're going to use our SOH CAH TOA. I'm going to bring that down and I'm going to show you how to solve some examples. So here's my SOH CAH TOA. Oh, I left off the part of the H there when I brought it down. Okay. Now, the first thing I want you to do as we go through these is turn your calculator on. And then on your calculator, you'll notice at the top, there should be a letter. If you look at the display, there should be a little D there. If there's not a D, your calculator is set incorrectly and you're going to get some wrong answers. So what I suggest you do is you press the shift button, which is the top left. So press the shift button and then press the button that says setup. It's right next to the on button. And you'll see a whole lot of options come up. And hopefully you can see that one of them says 3 DEG, DEG, standing for degrees. So press 3 and now you should be set to degrees and your calculator will be working for trigonometry. Most of the time you just want your calculator set so that that D shows up the top, okay? If you have any particular queries about your calculator, it's not, you can't set it up or whatnot, just let me know what's wrong, what you can see on your display, and I'll be able to fix it up for you. Okay, so we're now set to degrees. Let's start labeling this first triangle here. We'll call this question 1. This is our angle, and this is the right angle here. So we can label this as a hypotenuse. And what do you think the A will be? Is it going to be opposite or adjacent, this unknown side here? Is it opposite or adjacent? Well, you can see hopefully it's opposite the angle, so we're going to call this opposite. So you can see we've got an O and an H, which means we must be using the sine ratio. And here's what we do. Get ready. You might want to write this one in your books. We go sine 27 equals opposite over hypotenuse. Okay, so sine equals O over H. The first letter goes on top, the second letter goes on the bottom. Okay, and then don't put that on your calculator yet. We don't know what O is. We've been given the variable A, so we're going to write A, but we do know that the hypotenuse is 10, so I'll write 10 next. Now we want to find out that unknown side A. That's what we're trying to do here. So we need to get the A by itself. Now how are we going to get rid of this 10 at the bottom of the fraction? Well, of course, we're going to need to multiply both sides. So the next step is to say A is equal to 10 times sine 27. So pop that into your calculator now and see what you get. 10 times, press the sine button and it'll come up with sine bracket, 27. It's a good practice to close the bracket afterwards, especially when we get to more complex calculations. Then you press equals, and I'm getting that A is equal to 4.54, and that would be my answer. Maybe I could even just go to 4.5, I don't know. I've done 3 significant figures though. So that is our first one. Well, let's take a look at the second one. We straight away can identify this as the hypotenuse, and the C is not opposite. This is actually an adjacent. We've got an A and an H. Now, which of our 3 SOH CAH TOAs has A and an H in it? You can see that it's this one. That has A and H in it. And cosine is equal to the adjacent divided by the hypotenuse. That's the ratio that the cosine button on your calculator has all the information stored for. So what we will write in this case is cosine 58 equals A, which in this case is the unknown letter C, over the hypotenuse. Now we're told the hypotenuse is 7, so we put it over 7. And we can rearrange the formula by multiplying both sides by 7. So if I times this by 7, you'll see that will cancel that out, and then I'll get 7 times this. Okay, so that's what we're going to do to get to the next line. So I will get, I'll just cross that out. C is equal to 7 times cosine 58 degrees. Now what does this give us? 7 times cosine 58. What does that give us? Check it on your calculator. Have a go. I'm getting 3.71, and that's to 3 significant figures. Now the next one, let's see what we've got here. I can label straight away this is my hypotenuse, can't I? Because it's opposite the 90-degree angle, and this is adjacent. So once again, I've got cosine. I've got an H and an A. Can't be this one, right? That's an O and an A, so it's not that one. And it can't be this one because that's an O and an H, so it's not sine. It's A and H, so it must be this one here, cosine. So again, I write cosine 67. Now this is where we can get into trouble, because remember, we are not chimpanzees carrying calculators. We are human beings with brains. We've got to apply things logically. We don't just put the we don't just put the unknown on the top. So we want the adjacent over the hypotenuse. So think carefully. What are we going to put over what? Which one is the adjacent? The adjacent is 1. So we put the 1 on top, and on the bottom we put x. Now we need to get the x by itself. So how are we going to do that? Well, the first step is I'm going to multiply both sides by x. So my next line would be x times cosine 67 is equal to 1. Now how do I get the x by itself here? Have a think. x equals, I'm going to divide both sides by cosine 67. So I'll do that. Now let's chuck that into our calculators and see what we get. 1 divided by, and on the bottom, you can do it as a fraction, cosine 67. Make sure you use your brackets just to get into that habit. And I'm getting that x is equal to 2.56. Okay, well I hope this is starting to make sense. Why don't we take a look at a few more examples to see if we can consolidate. Right, here are some more examples. We'll remember our SOH CAH TOA. Let's take this first example here. What have we got? This is our hypotenuse. Always label your hypotenuse first, okay? Always label your hypotenuse first. So it's that one. And then we have an opposite. This is the opposite. See, it's right across from that, opposite. And the adjacent, remember, touches it, touches the angle, but is not the hypotenuse. So it's this one. Now, what do we have here? We've got an A and an O. A and O is TOA. Okay, so we're dealing with tan this time. So tan is equal to opposite, the first one, over the adjacent, or divided by the adjacent. So we're going to go tan 25 equals opposite. Which one is opposite? That's our B, over the adjacent, which is our 8. So we can get B by itself by multiplying both sides by 8. 8 times tan 25. Now what does this give us when we chuck it into the calculator? Well, I'm getting 3.73. I hope you're doing this along with me. Alright, next one. Okay, we've got, this must be a right angle here. Let's just pretend that is. That would be a hypotenuse. We need to know the hypotenuse. And we also have this one here, we don't know, adjacent. This one is opposite. So we've got to find both y and x. So let's find x first. We've got a known here, a known side here, and an unknown here. So OA. So you can see that that is tan again. Tan is OA. So we're going to go tan 45. And I can tell you, we should know this straight away from what I told you right at the beginning. Think, make your predictions. Should equal opposite, which is O, over adjacent, which is x. Let's rearrange. So we get x times tan 45 equals 8. And now I need to get the x by itself. So to get from here to here, I multiplied both sides by x, because I can't have my x on the bottom there. So next line is x is equal to 8 over tan 45. And you should get x is equal to 1. Okay. Now, we also need to do this other one here, the y. So let's try that. Okay, doesn't want to change my pen color for me for some reason. I'm not quite sure why. Okay, I guess it doesn't matter too much. I would prefer it in a different color. Okay, so we've got a hypotenuse, and we know this here is our opposite. So we've got opposite and hypotenuse. Okay, so opposite and hypotenuse. So we're going to go sine, because opposite and hypotenuse is sine. So sine, and it's 45, equals opposite, which is 8, over the hypotenuse, which you can see here, is y. And we do that tricky one again. We times both sides by y, because we don't want the unknown at the bottom of a fraction. So we get y sine 45 equals 8. To get the sine 45 across, we divide both sides by the sine 45. And we get this. And then we just chuck that into our calculators and see what we get. 8 divided by sine 45 is You get a funny answer there, but just press S to D and it will give you it in decimals. So I get 11.3. Okay, so I hope that's makes sense for you. And the last one here is this one here. We can immediately identify this as our hypotenuse. This is our opposite because it's across like that from the known angle. And this one is next to it, so this is our adjacent. Always identify the hypotenuse first. So we have an opposite and an adjacent that we need to know. So we're going OA, which is again TOA. Well, we've got 3 tans in a row. So tan 28 degrees equals opposite over adjacent. And again, we've got this annoying thing with the x at the bottom, so what do? Same as the other ones. Multiply both sides by x. So we get x tan 28 equals 42. How do we get that tan 28 across to the other side? Oh, just like what we've done on the other side, other examples, we divide both sides by tan 28. So we get x is equal to 42 over tan 28. Okay, what does that give us? 42 divided by tan 28 equals 78.99, or x equals 79.0. Okay, well that's that. Now let's move on. Now sometimes we get some word problems, or we have to draw the triangles ourselves. So I think these are from your textbook, and the middle angle in these, like the B or the E or the H, these are actually your right angles. So I'm going to do 23, ABC. So you don't have to be fancy about this, right? Don't go crazy. Just draw a triangle, a right angled triangle. There's our right angle. This is B. This is A. This is C. Now what do I know about angle C? Oh, angle C is 40, so I can chuck that in. That's 40. And then BC is 4 centimeters. Well, here's BC at the bottom here, so that must be 4. And I've got to find AB. So this is going to be my X. So let's think about this. Maybe I'll bring my SOH CAH TOA stuff down again. There we go. There's my SOH CAH TOA. What have I got here, team? Well, you can see that this is the hypotenuse. This is my opposite, because it's opposite the 40, and this is my adjacent. So what have I got? I've got an A and an O. Oh my goodness, it's another tan. So I go tan 40 degrees is equal to my X, my opposite, over my adjacent, which is 4. Then I rearrange so that X is my subject. At least this one is a little bit easier. I just times both sides by 4. And then I can work it out on my calculator. 4 times tan 40 degrees. Then I'm getting on my calculator 3.36. Okay, I hope that makes sense. Let's do another one. I'm going to do 24 now. 24, I'll quickly draw my triangle again. So, we're stuck in that thing again, are we? Okay, fine. Oops, come back. Excuse me, team. No, it doesn't want to draw for some reason. Alright, we'll just turn it off and on. If in doubt, close it. Open it up again. Okay. Here we go. I'm doing DEF. Okay, so the middle angle in these is going to be our right angle. That's what the textbook says. Okay, so that's what we've got here. Let's put down the stuff we know. We know the angle F is 35.3, so this is my 35.3. And we know that DF is 7, so I pop a 7 here, and I know I've got to find ED. Oh, this is exactly the same as the previous one. So you can see, let's label our sides. Hypotenuse. Opposite, because it's opposite here. Oh no, it's not the same as the other ones. Wake up. Oh, OH. What do we got? We got SO. So it's sine. So I go sine 35.3. What do we know? Sine is equal to O over H. So, O over H. Now, O in this case is the unknown. It's the X. What's H? Oh, that's this bit here. That's my 7. So I pop it over 7. So then I can say that X is equal to, I times both sides by 7. So it should be 7 sine 35.3. So what does that give me? 7 times sine 35.3 equals, I'm getting 4.04. Or 4.05. Okay, now I might do another quick video in a minute, but I'll separate it into two because it's going to get too long for YouTube. Let's just refresh our memories over all of this. So the big idea today is I want you to be able to identify the sides. So first of all, let's clear some space. Let's go right down here. Okay, first of all, when you've got a triangle, identify your right angle. Then you know that across from that, this is your hypotenuse. Then look at which angle you've been given. Let's say you've been given this angle here. Draw an arrow across the other side, and that will give you your opposite. And then the other one that's next to it is your adjacent. Okay, so always identify the hypotenuse first. Now, SOH CAH TOA stands for SOH is equal to sine is opposite over hypotenuse. CAH means cosine is equal to A over H, adjacent over hypotenuse. And TOA is equal to tan is equal to opposite over adjacent. I hope that makes sense to you, team. This should, what I've done should enable you to do the first exercise of today's work, but there is another video that I'll do for this as well that will help you with the second one. Alright team, take care.